Great. What a privilege to be here today to talk to you about my pet project, actually, which is powering planes with poo. Bear with me here, okay? I'm going to tell you, I want to put this in some context. I'll tell you on a bit of a journey about how I've come to this conclusion. So it actually started back in the mid-90s. I was studying zoology at university, and we actually had a class on climate change, I guess, so building upon the presentation we had earlier. And it basically terrified me. You know, I could see that if we didn't make a big difference and if we didn't actually stop using fossil fuels, the world wasn't really going to be habitable. Possibly in my lifetime, but almost certainly in my children's lifetime. It wasn't going to be a great outcome. So this stuck with me. So when I left university, I did the obvious thing that you would do, is actually built a small bio-refinery in my parents' garage to convert waste cooking oil into fuel. Fairly normal in Stroud, which is where I was brought up, but for the rest of the world, a little bit edgy. And actually, this was quite early on. It was a real mess about 2 weeks later. But actually, this was back in, I guess, sort of 2002, 2003. And it gained quite a lot of interest. And so a lot of people contacted me and said, oh, God, James, yeah, we want to start making our own fuel. So anyway, we ended up, I thought, great, I'm going to start a business now. So I started my company, Green Fuels, and roll forwards 20 years, and we've now supplied equipment in over 80 countries, producing over 500 million litres of sustainable fuel every year. And the thing I'm most proud about is we've actually, through our customers, offset around 7 million tonnes of carbon. So it really, you know, I was very, very pleased with this, and quite excited about my new adventure in biofuels. One of the things I did find, though, with getting into an industry quite early, you've got to get involved with some quite cool and interesting projects. So we fueled the very first biodiesel racing car. We actually fueled the very first biodiesel train, which was actually the Royal train. I was very lucky to travel on this a couple of times. I must admit, the first journey was quite nerve-wracking, a bit like the event tonight, because I think I was mainly there in case I broke it. The second one was much nicer. I must admit, literally had the best breakfast I've ever had in my life. But so this was a fantastic thing to be involved with. But it became apparent by this sort of stage that the feedstocks that we were using, so waste cooking oils from chip shops and things, was quite a finite resource. So started to look at other sources of fuel that we could convert into, other sources of feedstock that we could convert into biofuels. So, for example, we looked at aquaculture waste and developed a fuel produced from fish waste, which we converted into something called a drop-in fuel. So this is kind of chemically identical to fossil fuels, but is a fully biogenic fuel. And I'll explain that a bit later. And we see this as potentially being great for sort of small-scale marine applications, but certainly it's not big enough to completely change the world. We also did some quite interesting things, like we worked with Aston Martin to modify a classic car to run on bioethanol, and it was used at quite a famous wedding running on our fuel. So again, really pleased I didn't break that one. And the fuel used in this, interestingly, was made from waste wine and cheese. So it was again a little bit niche, but it was quite a good opportunity again to look at these biogenic fuels for usage. But by this point, if you look now, so biofuels, you know, move forward 20 years, biofuels are everywhere. So if you fill your car up with gasoline at the pump, 10% of that's bioethanol. If you fill it with diesel, 7% of that is biodiesel. You know, it has now become the norm. And also there's electrification of cars, which I think is fantastic and definitely the right way forward for road use. So we had to look up for our next challenge. And the next challenge really was, how do you move big things a long way, such as aircraft, with alternative fuels? It is challenging because, to be honest with you, there really isn't much other choice other than fossil fuels, certainly for large aircraft. If you look at sort of the energy densities here, so if I was planning to power my plane on hydrogen, it would have to be basically full of the stuff because it takes up an awful lot of space. If I was going to power it by batteries, well, it's going to be very challenging to take off. So really, you need to have something that sits where that yellow circle is up there. Unfortunately, that's where your hydrocarbon fuel sits. So there's been a lot of development in the last few years around things called sustainable aviation fuels. So these are fuels that are effectively synthetic fuels, hydrocarbon fuels, but the carbon is made from a biogenic source. Just to explain what that is, so basically the source of that will have fixed carbon within our lifetime, so relatively recently, rather than, say, a fossil fuel, which is from carbon that was fixed millions and millions of years ago. There's now huge targets that have been put in place for aviation fuels, these sustainable aviation fuels. Across the UK and Europe, 10% of all fuels are supposed to be sustainable by 2030. In the UK now, we've set an ambitious target of 75% of our aviation fuels by 2060. And globally, by 2060, we're expecting to be using 285 million tons of the stuff. So, you know, it's a really, really big market, super exciting. But to be honest with you, there's not really any one way to be able to produce those volumes just yet. Which led us to this. My favorite thing at the moment which is sewage. So sewage is everywhere. You know, we're all contributing to it. We're all contributing this supply every single day. Some people more than once a day. You know, there's basically a lot of it around. The UK, we have, it's about 57 million tonnes per year, and you can imagine what the quantities are elsewhere. It's a very exciting feedstock as well for me. I'm a bit of a geek when it comes to this stuff. Obviously fully biogenic, but it's a real problem to get rid of. Currently, it's spread on the land as something affectionately known as cake, but that's being banned because it can run off into rivers and cause pollution. And the other alternative is incineration. But as you can imagine, setting fire to something that's 80% water is pretty challenging. So we came up with a process, or we looked into a process that could utilize this feedstock for producing fuels. And this is something called hydrothermal liquefaction. Basically, we're replicating what happens in the Earth's crust. So if you look what happens with biogenic material over millions and millions of years, and under pressure, you end up with crude oils. And what we do is we take our poo, we stick it effectively in a pressure cooker, and run that under sort of moderate temperatures and high temperatures, moderate temperatures and high pressures, to break down the larger molecules into something called a bio-oil or a bio-crude. And this is effectively like a crude oil. So you can then move into your sort of further upgrading and refining as you would do with a petroleum product. The co-product of this is something called biochar, which is also very good. It sequesters carbon, which is fantastic, but it can also be used as a soil improver and also in construction. And it has a relatively high value as well, which offsets the cost of the other products. So we've spent some time now developing a fully integrated system which we call Firefly to take sewage sludge all the way to aviation fuels. And we're hoping to be building our demonstration plant in the UK very, very soon as a world first for this specific application. And primarily for us, it's a way of qualifying the fuel for aviation use. As you can imagine, incredibly sustainable when you compare it to fossil fuels. So we appointed Cranfield University to do an independent study into the carbon impact of it, and we found that it was a 92% saving over fossil fuels. So to be honest with you, it's about as green as you could possibly get. Obviously, this has a big impact on a number of the United Nations Sustainable Development Goals as well. So it's affordable and clean energy. It's affordable because sewage sludge is basically free. Climate action, clearly big impact on the climate. And clean water because you don't get the runoff into the rivers, etc. Life on land, really, this is because we're utilising a waste material, so there's no indirect land use change. This is a material that is there. So as you can imagine, with this innovation, we are super, super excited about the potential and the future of this. So if you look at the potential in the UK with the sewage sludge we've got here at the moment, we can produce about 650 million litres per year. Within Europe, that's something like a further 3.6 billion litres. The US, another 2.7 billion litres. When you look at the rest of the world, it becomes mind-boggling. And you can see how this solution can be applied in lots of other markets where we can utilise the fuel. The other interesting thing you tend to find with sewage sludge, believe it or not, which I've learned recently, is that treatment plants tend to be away from cities and they actually tend to be quite near airports. You tend to bunch the things you don't like in one position. And that's kind of important for us because we want to minimise any transport impact of moving this around. And the facilities are designed to be close to the treatment works because the water is simply used in the to create the reactive conditions. It's not actually used in the reaction. So you need to be back towards the treatment works to actually put the water back into it. So I hope I've convinced you that the future of aviation actually is poo. And I believe this is... And I do believe that, you never know, next time you're catching a flight off on your holidays or off on a business trip, you may well have played your own part in fueling that. Yeah, what an exciting world we live in. Thank you very much for listening. I'm James Hygate.